Welcome to Haxby Shed. I'd like to tell you about my new video editing PC. I haven't built my own PC for about 25 years, but I couldn't get what I wanted from the main manufacturers, so I've decided to buy the parts that I want and put it together myself. My son put together a PC recently and he'd been researching for about 6 months, so I've benefited from all his research and pretty much I've bought what he recommended. But as I've checked it through, I've been very happy with the choices that he made. Here we can see the case, the motherboard, the processor, a Blu-ray burner, power supply, liquid cooler, 4 fans, computer memory, fast storage, slow storage, and in addition to this I've got medium storage and SSD which I can take out of my existing computer, plus also I can take the video card out of my existing Dell computer. I'll go through the main parts here one by one, explaining in plain English that I hope everybody can understand. When building a new PC, choosing the processor is a good place to start. And there's really a choice of two, Intel or AMD. Intel have their 10th generation processors and AMD have their Ryzen processors. The AMD chips are quite a bit cheaper than Intel, and actually they have more capability in general. So I've chosen this Ryzen 9. It's a big box, but it has a big heatsink inside. This is the chip itself. So it's a Ryzen 9 3900X, and this chip was about £400, so a third of the cost of the computer. I think the whole thing will cost me about £1,300 actually. It has 12 cores and it has a base clock of 3.8 gigahertz. Now if I compare that with my first computer, which was the Amstrad 1512, which I bought in 1986, and you can see a picture there at the back. That had an Intel 8086-2 processor, which clocked at 8 megahertz. So just think about how much technology has moved on since then. And the 8086 had about 29,000 transistors on it, and this has something like 3.6 billion transistors on it. The Intel 8086-2 had 1 core, so in other words 1 processor on the chip. This one has 12 cores, so 12 processors on the same chip. It's like having 12 people in a room all working hard together on the same task. So having chosen the processor, the next thing to choose perhaps is the main computer board or motherboard. And you need to get a motherboard that suits the processor family, and this one is for the AMD Ryzen family. You'd need a different board for an Intel processor, and there's many reviews of these online, and I chose this one, or to be more accurate, my son chose this one. So the main computer memory plugs in here, the processor plugs in here, the fast RAM plugs into these two here. The expansion cards, so your graphics card and any others that you have, plug into these here. And then all the other connections around the outside are for power and for fans and for USB ports and many other things, including the audio amplifier system here. And then this bit pokes out of the back of the computer, and you can connect many peripherals on there. So there's many USB ports, the Ethernet connector, the audio system, HDMI output, if you use the graphics which are built in to the motherboard. This is the memory that I've chosen, 16 gigabytes, DDR4 3600 megahertz. I could buy more than 16 gigabytes, but it doesn't make that much difference. This is the super fast storage, 0.5 terabyte. And this is the relatively slow storage, 2 terabytes. And you might say, why buy relatively slow storage when you can get this super fast storage? But the fact is that this super fast 0.5 terabyte was about £100, whereas this relatively slow 2 terabytes was only £50. So for bulk storage, where you don't need super speed, these hard disks are still very good value and have their place. Now most of the other components are pretty much what they say on the box and are not that exciting, but this cooler is worth a mention. So back in the day, processors were always air-cooled, but in recent years there's been a selection of water coolers on offer. So we have a radiator, we have some pipes, and we have this cooler block which sits on top of the chip. Now you can get these with double radiators, triple radiators. There's 2 fans, one that pushes and one that pulls, that go at either side of this radiator. But we don't have a lot of space in the case. I didn't want a huge case. But I'm quite confident that this will be sufficient because the chip only consumes 105 watts. And that's not very much because my 12-year-old Dell that I'm using now, my XPS 430, that chip, which is only a 4-core chip, gives out 105 watts. And that cools very easily with an air cooler. So I don't think cooling this chip is going to be too much of a problem. I'm confident that this will be fine. Well, I think that takes you through all the parts that are worth talking about now. I'm not going to go through a blow-by-blow account of building the PC. There's plenty of videos on that on YouTube. I'll add to this the GTX 1060 video card that I have in my XPS 430, my Dell PC now, plus the 1TB SSD. But once the PC's built, we'll come back again and look at the performance using the video editing software and compare that, which should be phenomenal, against my XPS 430. Well, the PC's built and it passes the power on self-test. So the next thing to do is to install the operating system. When you first start the computer, it's a good idea to go into BIOS and check that all the components have been recognised. I say BIOS, it's actually called UEFI now, but I think most people still call it BIOS, Basic Input Output System, and it's this layer of software which is on the motherboard, which interfaces between the operating system, say Windows, and the hardware. We can see the fans and how fast they're running, and you can set up different profiles for the fans. Now, to be honest, my case doesn't need this many fans. The cooling for the CPU is handled anyway by the water cooler, except that has 2 fans. But if I was running a very fast graphics card, if I was playing the latest flight simulator at 4K on a big screen at 100 frames a second, then actually the graphics card would need a lot of cooling, and really that's where the fans come in if the graphics card is air cooled. For each of the fans you can set up a profile. Here's an example. So this is the CPU fan. It actually drives a pump on the water cooler, so it's perhaps not a great example. So here I've chosen System Fan 1, which I know is the fan at the front of the case, and at the moment it's running at 639 RPM because it's only at a temperature of 34 degrees. But as the temperature goes up, the fan speed would increase according to the curve that I've set here. There are many benefits to building your own computer, but one of the risks is that you'll find some incompatibility. If you buy your computer ready-made from HP or Dell or somebody, Asus, all of these things will have been fully tested. So here on the table we've got two sets of memory. They look identical except this one says 3200 megahertz and this one says 3600 megahertz. We built the new PC with the 3600 megahertz memory, but we found that occasionally it was blue screening. And when that happens, there's always the question, why is that? So you try a few different drivers, and if that doesn't seem to work, well, perhaps it's the memory. And it was happening quite randomly. It could run for 5 minutes or it could run for 5 hours. So I did some memory tests and it became clear, yes, there was a problem. Now my son had built his PC with the same motherboard, but with this 3200 memory 3 or 4 months ago, and so I borrowed his, tried it in, and it worked fine. So it's just something marginal about the timings with the faster memory. On the spec, the board certainly can run memory a lot faster than 3600. There's just some incompatibility. Each memory stick has a table on the back. You probably can't read it, but I'll include a still. But there are a series of numbers on the back here, and there's a chip inside, and the motherboard reads those numbers, and those are the numbers that tell it how fast it can clock the chip and how to clock the chip, because there's a cycle time involved. It takes a little bit of time for the electrons to whiz around inside the silicon, and so when you've done a write, you have to wait so many clock cycles before you do a read, and so on, and that's what these numbers relate to. Now I could have tweaked these numbers inside the BIOS on the motherboard, and then it might have worked 364 days out of 365, but I didn't want that, so I decided just to downgrade to a safe memory speed of 3200. Now we've done all that and changed one big black box for another big black box, let's see how fast it is. Let's start with Cinebench. You can hear the fans revving up as the chip warms up. That's a Cinebench score of 7239. Now let's look at the storage. These tables show performance for reading and writing, for sequential or random access, and for differing numbers of threads and queues. The table on the left is for the superfast storage, the one in the middle is for the medium speed storage, and the one on the right is for the physical hard disk. Larger numbers mean better performance, but look how it tanks for random access, one thread and one queue. And looking at this, you would think the physical hard drive would be hopeless. But actually, it's perfectly fine for large video files where all the access is essentially sequential. Now let's look at the performance of video editing, which is the reason I upgraded the computer. And my test piece is this clip between these two orange arrows. And if I go to export, and I start the export now, you can see this blue bar whizzing along the bottom here. And I can tell you that's going to take 9 seconds. And before I upgraded, it was taking 54 seconds. So that gives you some idea of the improvement with this upgrade. As I was doing the performance test there on the video editing, the processor was loaded at 65% and the graphics card was loaded at 55%. So actually they're quite balanced. And it shows that you don't need a super duper graphics card in a video editing PC. I'd like to leave the last word to this Amstrad 1512. Back in 1986, these were about the first affordable home PCs. The IBM PC then was really aimed for business, and it cost about £4,000, so really unaffordable for the average family. And I had a bit of money, I'd moved jobs, and I got some cash back. And I decided to invest in one of these, and it meant from the very beginning all of our children had access to a home PC. I hope you enjoyed that. Thank you for watching Haxby Shed.